Welcome, everybody. We're going to spend 1 hour talking about composite models. Before start to speak, thanks for all the sponsors. Remember, these conferences would not be possible unless we had sponsors, because I have no idea how much you paid to be here, but for sure that is not enough to run everything and manage everything. So all what they're asking is just that you go there, take a look at their products, and maybe have a chat with them. Do that, and future conference will still be something. With that said, I'm Alberto Ferrari. I work with Marco Russo at SQLBI.com. We do a lot of things, everything related to the DAX language. We mainly write books, we do training, mastering DAX. The new Optimizing DAX workshop, it went online like 2 days ago. It's massive, it's beautiful. We enjoyed so much recording it. Take a look at that. It's really, really interesting. And then we do consulting and other stuff. But I'm not here to sell myself. The goal of today is to talk about composite models. I guess you all know what Power BI is. Everybody's using Power BI, right? Say yes. Cool. Composite models is the feature that stayed in preview for the longest time in the history of analysis services. I honestly have no idea why it stayed in preview for so long, but it's really an extremely powerful feature that lets you extend remote model with local models. It is very nice, it is very powerful. As any other technology in analysis services or on this planet, it comes with limitations. And I want to introduce composite models first, then we look at some demos. We understand how the technology works from the inside, because despite the session being introducing composite models, I cannot help talk about some internals. And we will see the details of how they work, because these are important. It's very easy to use composite models the wrong way and build an entire architecture that simply will not work. You will have a lot of issues. That's because you are using them for the wrong reason. Now, in order to talk about composite models, we need to first briefly remind what are the three engines that are in analysis services, Power BI. Power BI and analysis services, they are the same engine. There is the Vertipack engine, the model that we all use all the time, import mode. You have data in some data source like SQL, you load it in a new database that is Vertipack, and data stays inside analysis services. But that is the fastest and the best way to store your data, but for some reason, people want to also use direct query. Anybody here using direct query over SQL? Raise your hand, don't be shy. I know you are there. There is somebody, of course, that is using direct query. Direct query works, it's nice. Again, that's a technology that most people use for the wrong reason, because the reason to use direct query for relational sources is whether you have a gigantic database, so a very, very large database that doesn't fit in RAM, but you can always buy some RAM, or when you want real time. These are the two main use cases for direct query. The main difference between direct query and Vertipack is that in Vertipack, data is loaded inside the database, the analysis services database, whereas in direct query, the data stays in SQL Server, and whenever there's a query, the query is sent to the SQL engine, and the data is queried in a very dynamic way. It worked. It gives you the option of creating gigantic models or real-time models, but I'm not here to talk about direct query. The new storage engine that was introduced first in preview and now, since probably a couple of months, is in generally available, is direct query for analysis services that finally are called composite models. Originally, they were composite models, then they called them direct query for Power BI and Azure datasets on analysis services, like a name that is a theme by itself. Now they call them composite models. With composite models, the data is in the remote database, and it is an analysis services database. You have the option to connect to that analysis services database and then extend it through local tables, calculated columns, measures, calculation groups, whatever. And the data stays in both places. You have a remote database on the cloud, and you have a local database that is local to your model. And there is, of course, a communication between the two engines. These are the main storage engines for now in analysis services: Vertipack, Direct Query, and Composite models. The choice of the storage engine is extremely important, because if you are seeking for speed and flexibility, then Vertipack is the best choice. If you are seeking for real time or for really huge data models, then Direct Query for relational sources is probably a better choice. Direct Query for analysis services or composite models, this is a technology that you use when you have your own corporate database, a very large model with all the calculation and all the numbers that need to be computed for your company, but then you want to extend it with some tables or some calculation which are specific of your business. Maybe you are doing budgeting and you have the sales corporate model containing all the data, but you want to add your budgeting table so you can forecast and do further calculations. So you have a very large model that can be extended. As we are going to see, composite models are definitely not an architectural technology. Do not even think about creating one layer of models and then below it another layer of composite model and then below another layer and maybe another layer where you slowly extend the power of your corporate model and then pretend to make that work, because it's not going to work. Composite models are designed to extend with a small number of tables a corporate model, and that is what they are made for. If you use that for this reason, everything is going to work fine. If you use them in the wrong way, then good luck with that. You will have a lot of issues just because you made the wrong choice at the beginning. And just a couple of slides to repeat the concept. When you have a Vertipack model, data is loaded, and the model is local to your Power BI file or your analysis services. So the operation you made from the data sources is that you copy data and you place it in a new model. Now, everybody hates copying data, and that's the reason why everybody now wants to use Direct Query and other technology, because this copy operation might be expensive for large models. But at the same time, you have the great opportunity with Vertipack models to reshape your data. The data modeling part, creating a star schema, building relationship, and building all of your calculation happens inside the Vertipack model without having to touch the SQL Server database. If you don't like copying data, you can use Direct Query for analysis services, but if you have the model that is placed on the cloud, then you can create a live connection. And this is where we are going to start. I'm not going to spend more time on slides because these are just boring. And on the other hand, I want to open a new Power BI file that basically contains nothing at the beginning. And we connect live to a model. I have Contoso already published on the web, so all what we need to do is connect to a Power BI dataset. I have all my Power BI dataset, we use Contoso 10K, and we connect to that. What is happening right now? I'm not creating a model right now. If I look at the diagram, you see that the tables are blue. Blue means that this doesn't mean sad in this case, they are happy tables, but the tables are not in this model. They are still in the cloud. No data is being copied locally, but I have all the tables and I can modify them. I can do calculations. Data is not here. You see here, I do not have the data view. I cannot look at the content of the tables because the tables are not here. And I can build my matrices. I just take the sales amount, drop it here. I can place the margin, make a matrix out of it. And with a larger font, because I don't know about you, but I cannot read at that size. And that's always hard to do. Let's go for 20 maybe. Cool. So we have the sales amount, we have the margin, we click on product, slice by brand. Everything is working, but it is important to understand what is happening right now. So where is this calculation happening? The data is not on my PC. The data is in the cloud. The analysis services engine is in the cloud. My PC is using a live connection. Being a live connection, I send a query to the remote engine. The remote engine processes the query, sends back the result, and Power BI is nothing but a client tool. I can use it to browse my data and get insights. I have some modeling options. let's pretend that sales margin is not, I want to compute, for example, the percentage of the sales amount across all the brands. I don't have such a calculation here, but I can build one very easily. I build a new measure with a larger font, create, for example, a percentage with the right keyboard, which is the division of the sales amount by calculate sales amount for all product brand. I have my measure, I format it as a percentage, I place it in the report, and I'm happy. The calculation happens, I have my percentage, and all the numbers are fine. Again, this calculation is not happening locally. This calculation is happening on the remote server. If we look at this, at the query that is being sent for this query, you will see that the measure percentage is defined as a query measure. I can go to optimize, open the performance analyzer, start recording, refresh my visuals, look at the matrix. I copy the query that has been created. And if I look at that in DAX Studio, you will see that there will be a measure defined locally. We have this defined measure sales percentage that divides, this is the code that I just wrote, and this definition is part of the query. So I execute only one query, and this query is entirely executed by the remote engine. I have the option of creating measures. I have the option of doing simple calculations. But let's pretend that I want to slice my product by one column that is not part of the model. So I have in my product table several columns, the brand, the category, and stuff like that. But maybe I want to understand whether I sell more cheap products or expensive products. And I can define that a product is cheap if its price is less than $100. And I want to slice by that. The problem is, if I right-click here, I can build a new measure, a new quick measure. Anybody using quick measures? Say no. Cool, I love you. So you can build a new measure. You don't want to build a new quick measure, of course. But in this case, I want to create a new column, and I have no option of doing that. I cannot create a new column because the data is not stored here. Calculated columns need to be stored somewhere. They are computed, and then they are stored in the table. So they are part of the processing. But the data is not here. Therefore, I have no way of creating a new column. That makes me sad, because with live connections, I can extend through measures a remote model, but I cannot do much more than that. I cannot extend with new columns. I cannot create new tables. I don't have multiple options. If I want to extend it further, so to go to the next level, I just need to go here at the bottom where it says connected live to the Power BI dataset, yada yada. If I want to make changes to this model, I have this inviting hyperlink, and if I click on it, I have a warning that says, hey, if you want to make changes to your model, like renaming columns, I didn't notice that, but renaming columns is not an option, you need to switch to a direct query connection. This requires adding a local model to your file. It is a permanent change. Of course, either we understand it or not, we just go forward, and we create a local model. Now, what is happening right now is something completely different. We switch from a live connection where data is in the cloud to a direct query connection where the metadata is both in the cloud and locally. The data is still in the cloud, and I will have the option of creating new tables and new calculated columns, new entities in the local engine. When you move to a direct query model or to a composite model, you have the option of choosing which tables you like to connect and whether you want further tables, so tables that will be added later to the model. I'm happy by this choice, meaning that whenever the remote model will be updated, I will receive the refresh here. It's making some metadata changes, and apparently nothing is going to change. I still see everything as it was before. I have my percentage. You might have noticed that the format string slightly changed because now it has a local format string. And now here it says storage mode direct query. The tables are still blue, but you might notice below here this Power BI API powerbi.com. That was not present before, and that states that the table is a local table, but it is connected through a composite model to a remote table. And the most interesting thing is that I can now go in the product table, right-click. I have the option of creating a new measure, and I also have the option of creating a new column, or manage relationship, or do operations that were not possible before. Let's remember, my goal was to slice by the price of the product. So let's call this product category. And I just write if the unit price, I just need to find the unit price is less or equal than 100, then this is a cheap product. Otherwise, it is expensive. As you see, I'm really good in doing business analysis. And we can get rid now of the brand, and we slice it by my product category. Place it on the rows, and it's working. Well, my percentage is not working. That's not interesting, but it's slicing by expensive and cheap. So think about that. I just created a calculated column in the local model, but the calculated column belongs to a table that is actually stored in the remote model. So a question is quite natural at this point. Where is this calculated column? Is it stored locally? Is it created on the remote engine? So I'm changing the model that is in the cloud. And what happens if somebody else makes some changes? Will I see them? The answer is that this is a very special kind of calculated column as any object in composite models, because it is a calculated column, but it is computed on the fly at query time. Let's take a look at the code that is executed now to fill this matrix. We need to open again the performance analyzer, start recording, refresh the visual. Let's take a look at the query. And when I paste the query inside DAX Studio, it says, hey, there are multiple query types detected, because there is a SQL query, and there's also there is a query that it calls a SQL query, but there is both the query, the direct query, and the DAX query. Let's copy both of them for now. Now, this is the first query that is executed, is the DAX query executed by the local engine. Remember, we now have a local model, a local engine that is running on my PC right now. So we have the metadata and the model that is entirely local. And on top of this model, I can run a DAX query. But when the DAX query is executed, it needs to be translated into another DAX query that is sent to the remote engine in order to let it execute the query. In the local model, I can reference the column product category, because I do have the product category column, the calculated column, belongs to the local model. But this query, this is the only query executed by the local engine, is translated into a different query, the direct query that is executed by the remote engine, where I have the definition of the column. The name is always ASDQ, Analysis Services Direct Query, product category, the name of the column, with the DAX code that is being executed. And inside the code here executed by the remote server, I can reference the ASDQ product category. I cannot reference, of course, any product category column, because the product category column simply does not exist on the remote engine. This type of query, the query that I'm executing right now here, is what we call a wholesale query. So the code that I generate is entirely executed on the remote server. We have a DAX query, local, and this DAX query is sent remote to the remote server. So the local DAX query references local measures or local columns. These are translated in a different query that is executed entirely by the remote server. And my local engine right now is acting just as a pass-through. It's not doing anything special. Now, what if I want to do something different? For example, I might want to cluster my product in a different way. Let's pretend that I want to do the same operation, but I want to create a copy of the product table. So I can go here, modeling, create a new table. No, let's make the sales by brand. Let's create a new table, brand sales, where I just use summarize columns by product brand, amount, and I just compute the sales amount. Now, this is now a calculated table that executes a piece of DAX code that will be executed remotely, but it is a calculated table. Because it is a calculated table, it is created, and then it is stored. Where? Here, in my local model. You see that now I do have the data view. It was not there before, now it is there. And through the data view, I cannot look at sales, because sales is a remote table. I cannot look at currency exchange, but I can look at brand sales, because brand sales is a table in the local engine where I can do, that is stored in the local engine. What happens if I create a new matrix? I get rid of the product, I get rid basically of everything, and I just slice it by brand sales. So I take the brand, I place the amount, I'm looking at numbers, I see them, but the question is, which engine is executing this query? Well, this is an entirely local table, therefore the table is queried only by the local engine. And that is a query that is executed entirely locally. We can always double check that. We open Performance Analyzer, take a look at the visuals, and the second matrix, hopefully, is the one that I'm interested in. You see that we do not have two queries, we only have one query, and that's it. Of course, now that we have two tables, why not create relationships between the two tables? I have my table here, brand sales, I can move it near to product, but I need to find product. There it is. And I can build a relationship between brand and brand. It will be a many-to-many relationship, of course. We want, now it's a many-to-one because brand sales is a key there, that's fine. Now brand sales slices the product table. So brand has a relationship with product, that has a relationship with sales. That means with the matrix where I'm right now slicing by the brand, I have the sum of amount, that is this column, but I can now take the margin percentage, drop it here, and it's working. Now, just focus for 1 second about what is happening. I have created a local table that is generated by querying a remote model. Then I created the relationship between the local table and the remote model. And now I'm making a query that queries the local table, a measure that is local, plus another measure that uses the relationship, but it is executed remotely. This is no longer an wholesale query. This is what we call a retail query. Part of the query needs to be executed by the local engine, part of the query needs to be executed by the remote engine, and the two engines communicate together in order to produce a meaningful answer. The level of complexity of this architecture is just insane, because even though we use it in a very simple way, it's actually extremely complicated. I honestly have no clear picture about how they are able to manage the complexity of these relationships. But that gives you an idea about the power of composite models. You can create local tables. In this case, it's just a calculated table, but you can do the same with a budget table, and it just works. The engine handles the complexity of the calculation. Unfortunately, as with any other technologies, there are some limitations. The first and most important limitation is that some calculations cannot be wholesale. So cannot be retail calculation. For example, the calculated column that I created, because the calculated column is sent as a column query to the remote engine, it needs to be calculated entirely by the remote server. I cannot create a calculated column that uses local tables, or that performs calculation over local tables, because that would be simply too complex. And that is probably the main limitation. The second, it's not a limitation, but it's an architecture we need to understand really well. And that is whenever the local engine and the remote engine needs to communicate, they do that through the DAX query. Now, we have seen all the code of the queries so far. Let's take a look at the code of this query right now. We no longer have the performance analyzer. We start, refresh, look at the second matrix. Let's copy the query. And here we have, I want to see everything, the query that is being executed. Now, the local DAX query does a summarize column. Let's format the code. This is a bit longer than usual. A summarize column that computes the sum of brand sales amount and the sales margin. So this is only referencing local measures. When it goes to the direct query calculation, you see that things are no longer so simple. We have this group cross-apply aggregation. I messed up everything. Okay. Aggregation 0 that computes the margin percentage. That is only for the grand total. But this is the real query that is being executed. And the important part of this query is not understanding the detail. We have several DAX functions that have not yet been documented, like group cross-apply table, group cross-apply, depend on, non-filter. All these are functions that we are waiting to document because so far we don't know exactly what they do. But the important part is that because the remote engine does not know about the brand table that I created locally, I need to send the table through the variable1. You see that inside variable1, we have the content of Contoso, Whiteward Importers, Northwind Traders, Adventure Works. This is basically the content of the local table that needs to be sent to the remote engine, because otherwise the remote engine would have no clue about how to group the data. The remote engine will need to compute the margin percentage, but the margin percentage needs to be grouped by a column that is in the local engine. How is that possible? The only way is to send information to the remote engine about how to perform all these calculations. Make sense? Say yes, say no, I haven't understood anything, or yes, that makes sense.
We've got a question from the participants online.
Okay.
Isn't there also a limitation that calculated tables and calculated columns that use direct query data source are not supported when publishing the report to Power BI service?
I didn't get the question entirely. Is it asking whether there are limitations when you publish this on Power BI, on the service? In that case, the answer would be no. I mean, you can publish this model on the service, and you have the remote engine, the first Contoso, then we have this engine, this model that is connected to the remote model, and you can chain multiple of these connections. This is not a very smart idea because performance is going to suffer very quickly. But no, there are no particular limitation regarding this. Of course, whenever you refresh the remote model, all the data is automatically refreshed. Any kind of metadata refresh will be applied. So if I change the name of a column on the remote model, the first time you refresh the local model, it will be refreshed. And you have a lot of possibilities. I'm not here to go into these details. This is the kind of details you can easily watch by reading the documentation and look at other sources. What I want to show you here is a couple of demos where composite models work. They are just beautiful, but you need to pay attention to details. Let's keep these open for now. Let's just create a new. Now let's duplicate the page. Duplicate the page. Cool. And we kill this matrix because one matrix will be enough. Let's see a couple of examples where composite models might be a good option. What I did was just slicing by product, slicing them by the unit price, cheap or expensive with one calculated column. Cool, simple, good for a demo, but not really important. What I might want to do is something different. I want to create a segmentation table that says, well, any product that sold more than between 0 and 1,000 is low sales, between 1,000 and 10,000 is medium sales, between 10,000 and whatever number that is a product with high sales. And I can create in the product table a column segment that clusters my product. Now, the column segment is a calculated column that computes the sales amount of the given product, then searches for the segment which includes the sales amount of the current product, and then finds the value to store. So I can solve the problem of segmenting my product based on the sales of the product in a static way, just using a calculated column. And this works nicely. I have my segment table, everything is working. I have my configuration table, and I can slice the sales amount by segment because this is a calculated column. And I can slice, of course, also the margin percentage and any other measure because I have created a calculated column in my local model. I'm making it work and I'm happy. But in order to build this solution, I need to have a local model. What if the model I'm working with is the remote model? So somebody built a corporate data warehouse, I want to connect to that, and I want to create my segmentation table because I want to find new insights which are local to my personal experience. What I can do is just replicate everything in a composite model. That requires me to create first, not this, but this. First, create the configuration table. This is a calculated table that contains 3 rows that define the segments that I want to use to do my slicing. That's just a piece of DAX code, so I can just copy it, go here, and create a new table. This is, let's save it as composite model, so we see it. Let's call it a composite model. So we see in the title that we are actually working with a local composite model. In my model, I don't have my configuration table, but I can create one on the fly. So modeling, new table. I paste the code, and that's it. I have it here, my configuration table containing the segment, the minimum, and the maximum value. Okay? Next, I just copy the code of my calculated column. I know I can create calculated columns in the remote table, so I can just take all this code, this is static segmentation, go to my composite model, go on product, and create a new column. Paste it. The code is fine, but the big question for you is this going to work or not? You have like 15 seconds to answer, then we need to run, otherwise I don't have time to finish my session. Do you see any problem here? No, we don't need relationships, but let's take a look at the code together. That's a calculated column that computes the sales amount. Can the remote engine compute the sales amount? Yeah, that's a measure there. And then it filters the product segment table, where the segment minimum and maximum value include the value of the product sales variable that I created before. And here is my problem. Product segment does not exist in the remote engine. The remote engine has no clue about the very existence of this table. So how is the remote engine expected to execute this code if it does not have access to the product segment table? Then the result counts the number of segments and yada yada, does other calculation. But the problem is that I'm mixing in the same calculation that use local entities and remote entities, and this is in a calculated table, in a calculated column. Being a calculated column, its execution needs to be wholesale wholesale means the execution needs to be completed entirely by the remote server. The remote server cannot compute this column, and unfortunately, I'm in trouble. If I hit enter, all I get is this error warning that says, hey, the column product segment cannot be pushed to the remote data source and cannot be used in this scenario, which basically means you cannot create this calculated column because its execution is not wholesale. You cannot make the server compute this value. That's a limitation. We know that. But it's the first limitation that we see that actually is a game. It's breaking our toy. We are no longer able to build a solution that looked very promising. So the second question for you is, what now? Can I make this work in some other way? Sorry, much louder than that. One thing that I typically forget to mention is that my ears no longer work as I wished. So you need to talk with me as you would do with your old grandmother. Cry out aloud, very, very loud.
So you can copy the table code instead of the name of the table. Code of the table.
Okay, that is an option. Never thought about that. It might also work. Let me check it. In this case, that's a bit of cheating, to be honest, but since you mentioned we can give it a try, we can take the code of this, define a variable. Let's go in the segment. We create a new variable. Let's call it product segment, PS. And here we filter PS. We cannot use that, but that way might also work. Max X over segments of, I cannot use the name, but I can use segment that way. Now this code no longer references the local table, and if I hit enter, it's actually working. Let's see if it really works, but it should. Let's get rid of the product category. We place the segment on the rows, and it's doing its job. We have the segment, the sales amount, and the margin. So it works. And not to say that I'm really a big fan of this, but it does its job. The problem, if you want, is that it works in this very special case because I can copy the code inside the measure. But as you might guess, this code is likely to come from some Excel file or some CSV files or some whatever that contains data that users manipulate all the time. But it's already a good step in the right direction. So if you want the code to be executed remotely, what you need to do is make the code wholesale. So that is a good option. Do we have anything better? Keeping the product sales table? Well, the answer is yes. It's only a matter of whether we find it quickly or not. Otherwise, I give you the answer. No, that's fine. That's the reason I'm here. If you want to make this calculation work without relying on this calculated column, you can do that by changing slightly the entire model. Let's remove this segment column. It was nice, but it's now time to die. We still have sales amount and margin, and we want a calculated column. We have the product segment table. Now, the product segment table contains 3 rows. Where is my product segment table? Mean value, max value, low sales, medium sales, high sales. The problem is I cannot create a relationship with this table. It would be nice. We know we can create relationship between remote tables and local tables. They work. But I cannot create a relationship with this table specifically because the relationship would be between the sales of the product, which is a given number, that needs to related to the row that includes min value and max value, and I cannot create such a relationship. But what I can do is change a bit the model. I can create a new calculated column in the product table, and let's call it sales amount. No, let's call it product sales. Product sales, that is just the sales amount. Now, my product table contains a column containing the sales amount. I don't see it here because I don't see the product, but I do have a column in product that includes the sales amount. The thing is, can I create a relationship between that column and the product segment table? No, I can't, because I have the given value of the sales amount, but I need to relate to one of these rows, and I have only 3 rows. But, come on the next sentence I'll give you the solution, so that's your only chance to... No, you want the solution. What I can do is create a new table that contains all the possible values of the sales amount, and for each value of the sales amount, the category to which it belongs. Let's build it together. Let's get rid of all this stuff. I can evaluate product, for example. Now, evaluate product doesn't work. I probably not connected to the model. I need to connect to my composite model. If I run evaluate product, I execute it and I obtain the entire product table. Among the many columns of the product table, you see that I have product sales. That is the column created by the composite model. So can I evaluate values? No, wait, I can see that lowercase. Values of product sales. And the answer, of course, is yes, that query runs nicely and provides all the possible values of the product sales column. Now, for each value, I can generate a table that filters the segments, the product segment where the product segment min value is less than product sales, product sales. And at the same time, we want the product segment max value to be greater or equal than the product sales. The result of this query, once it finishes, is that it says, well, if a product has this value of sales, its segment is low. Min value should be less, max value greater than. No, that is right. Between 0 and 1,000, that's 161,000. It cannot be low sales, of course. I'm wondering what is wrong here. The minimum need to be less, the maximum need to be greater or equal. What am I doing wrong? You mean it's the opposite? Okay. I trust you because I have no idea where the problem. No, that is not. No, the minimum value should be less than, the product says. The maximum value should be greater or equal. That can be greater or equal. I don't see a problem here. But this value is for sure not between min and max. That is granted. You mean I'm an idiot? This is actually 764. No, let's make it clear. Americans have no idea how to format their numbers, because that would never happen in Europe. So let's pretend that this is working. Now we have the code of the table, and we can create a new table. Let's go to home. No, that's a composite model, new table. Let's call this segment expanded with the code. The table is here. Now I have a table that contains the product sales and the segment. And guess what? I can go in my model and do something really dirty, like taking my segment expanded, move it near the product, then take the product sales and build a relationship between product sales and product sales. Unfortunately, I do have a circular dependency error, which I guess depends, because in the product table I use product sales, compute it this way. That should be calculate sales amount, all except product key. Let me see if I did it correctly. Now product sales, not yet. Much louder than that.
You need to select columns to break.
No, why that? That was working a year ago. So it should work, generate, oh, values, distinct. Okay, my bad. Let's see if I'm more lucky right now. Okay, now it's happy. This relationship has cardinality many to many. Of course, we trust it. Actually, it should not, but let's pretend it works. And we want segment expanded to filter product. Now, I'm going to use that in the report, like take the segment from segment expanded, build the filter, and make that work. Just the segment need to be on the rows. So I have the value for sales, the value for margin, the value for margin percentage. Now, again, I want to focus for maybe 30 seconds about the hell that is happening here. I have created a calculated column in a remote table using code that is defined locally. Then I created a calculated table that queries the remote table and the local table, merges them to build a local table. And finally, I built a relationship between a column that does not exist in the remote model. I compute it on the fly here, but I use it to create a relationship with this local table, and then I browse everything, and it's just working. That's insanely complicated, but it works. The thing is, as you have seen, it's not that easy. It's not that simple. It's not that you just start writing DAX code and everything works nicely. You need to pay attention to several details. And things are even a bit more complicated when you have a solution that works, but not in an efficient way. I want to show you another example. That is the dynamic segmentation. These are two patterns that you can find on daxpattern.com. That's why I'm not spending time explaining the details of the DAX code. I'm more interested in showing you the differences between the code when it is executed locally and the code when it is executed remotely or through a composite model. Now, this pattern is slightly different. I still have a segmentation table, low sales, medium sales, and high sales. But this time, I want to use this segmentation to cluster my customers. I want to cluster my customers saying, well, any customer that bought between 0 and 1,000 is in the cluster low, between 1,000 and 10,000 is medium, and more than 10,000 is high sales. The main difference, what I want to obtain here, is that I want this clustering to be dynamic. Dynamic means that the result I want to obtain counts the number of customers that year by year are in different segments. This is the result I want to obtain. In 2017, I had 459 customers that were in the low sales cluster, so they bought between 0 and 1,000. In 2018, there were 1,854, and then 656, all the other numbers. What makes this pattern more interesting than the other one is that now the clustering happens dynamically. If you think about that, you might have a customer that in 2017 was here, in 2018 went there, then in 2019 was part of the few ones with high sales, and then in 2020 went in a different cluster. So I cannot create an association between the customer and the cluster to which it belongs. That needs to be dynamic. And in order to make it dynamic, I cannot create a relationship. This time I need to write everything inside a measure. The advantage is that being dynamic, you can use slicers. For example, I can go on product, place the brand, make a slicer out of it. And then I just select Fabricam and Contoso, and the numbers change. And the same customer that maybe before was in medium sales now goes in low sales because that guy does not buy Contoso or Fabricam. So the calculation being dynamic makes everything a bit more exciting for users. And again, that is a calculation that looks nice when pushed on a remote model. What I need to do is build my segmentation table, that as you might guess is still a calculated table as it was before. And then I have the measure. How is this measure? Segment. I call the measure segment. That is not very smart, but no. Oh, customers in segment. Okay, the measure is customer in segment, but I don't find it. Where did I place that? In sales segment, of course, at the worst place where you can place a measure. I have my customer in segment that iterates over the segment, computes the minimum and maximum sales, then computes the customer that are in that segment by filtering the customer where the customer sales is greater than the minimum sales and minimum the customer sales. We have a variable just to save computing sales amount twice. This works, it works nicely, it just fine. And all what I need to do is copy both the sales segment table, this code, on the composite model, and then rebuild the measure. Let's do that. We start from the table, sales segment, I copy, I go on the composite model, create a new table. I don't know you, but I never find new table for whatever reason. New table, here it is in modeling. We have sales segment. That's a calculated table that is stored in the local model. Then I copy the customers in segment table, copy everything, and create the measure. Let's play it in sales segment too. So we replicate the same calculation. Now, before we move further, no, we actually don't have time, but before we look at that, is this code fine? Yes, this is a measure. A measure is not restricted to be all sale. It's mixing sales segment and it's mixing customer, so it's using both calculation, but it works just fine. And we can use it. We can go here, get rid of this entire calculation. We place the sales segment on the rows. From date, we place the date in the year on the columns, and we get an error, but the last step is we place the customer in segment measure here. It's not exciting in terms of speed, but it works. So it's just good. And we might be happy, but what I want to show you is that if you think about this measure, despite working, it requires the two engines to communicate. We have an iteration over the sales segment table. That is a local table. Then we are grabbing the minimum and maximum values. And then we are filtering the customers. For each customer, we need to compute the sales amount and then check whether this condition holds true or not. So the same calculation has two variables that compute values from the local table, a third variable that contains a reference to the remote table, and then we count what remains in this table. It's interesting to guess which engine is going to execute this code. Is it going to try to push the code to the remote engine? But if that is the case, it will need to send the sales segment table to the remote engine. Or it performs the calculation in the local engine. If that is the case, it needs to retrieve the customer table. In either cases, there is some data that needs to be moved back and forth. Let's see what was the choice. If we, as usual, open the performance analyzer, start recording, then refresh this visual, you see that the matrix is not super fast. It takes around 3 seconds, which is not a lot of time. But when we copy the code here, it says, hey, we have multiple query types detected. I want both. And this is, let me make it smaller. This is the query that is being executed. What is this stuff? Well, I told you that the engine had two options. Either it sends the table, the local table to the remote server, or it retrieves the entire customer table. And that's exactly what it did. The engine retrieved the entire customer table and then had to send it back to the remote server, storing it into a variable to build the calculation in a suitable way. This is customer. And I don't know what you think about this query, but that is a nightmare. I guess there is some developer out there that had to change the limitation in the size of a DAX query just to accommodate for this. If you write code and you reference, for example, sales, and you write the code the wrong way without paying attention to these details, you are going to kill the performance of any server because these tables tend to be gigantic. That is not to tell you that composite models suck. They do not. They actually shine for a lot of good reasons. You need to pay attention. The customer in segment table is a measure that is just written in a poor way. Why on earth are we filtering the customer table? Do we actually need to filter the customer table? No, we don't. Why don't we just filter one column, filtering values values of customer key, still produces correct code. It just works. The difference is that I'm not referencing an entire table for no reason. I'm using the minimum number of columns that are needed to compute my calculation, which, by the way, is a very best practice in DAX. By doing this small change, so instead of filtering a table, you reduce the number of columns that you are filtering. If we just clear everything, refresh the visual, and look at the matrix, well, first of all, look at the timing. We move from 3 seconds to 800 milliseconds, so the query is much faster. And when we copy the query, we paste it here, we want everything, and this is the code that is being executed. We have the local DAX query, and this is the remote DAX query which are being executed. That is very, very different from what we have seen in the previous piece of code. So what is the final conclusion about composite models for this introductory session? Composite models are really powerful. You can use them for a lot of interesting calculations. They extend the model. Actually, I don't have a final slides, so I will finish on this. Composite models are cool. They are extremely powerful, but you need to pay attention. You need to pay attention not to create calculations which are too complex. You need to pay attention to build the model the right way, obeying the limitations, and knowing that most of the limitations can be overcome. But you need to think about and build a different model, not just the first model that comes to your head. And second, when it comes to writing the DAX code, if you just give composite model to your user saying, hey, write the DAX code you want and then you will be happy, That is unlikely to work because unless they know exactly what is the difference between using values of product sales product key or sales, and I just reference table just because the code that they will write will be transformed into awful code. This is likely to change over time. I'm pretty sure the optimizer will address these problems, but as of today in GA, the optimizer is not yet good enough to understand bad DAX code and turn it into good DAX code. So they work, but you need to obey their limitations. With that said, they're absolutely beautiful. I honestly love them, and I'm pretty sure that in a lot of companies where they will use them for the right reason, they will provide a great solution. It's just that as any new technology, you need to spend some time studying them. As usual, I used all of my time, so we don't have a lot of time for Q&A, but if you have questions, do we have time? Maybe there's lunch right now, I don't know, or do I have a speaker after me? There is a break, so we can spend the break together here if you want to ask any question. But as I said, I'm staying here for any question you have, so if you want to ask them now, that's fine. If you want to come later, that's fine again, and I hope you enjoyed it. Thank you.